Hello, everyone. Today, Martin and I are very proud to present the great functionalities that our CMM development team have prepared for you this year. But before that, let's revisit how this CMM development project started 8 years ago. It all started with a dream. We wondered if it would be possible to bring the user-friendliness and flexibility of portable metrology systems to the CMM world, helping our customers improve their teamwork efficiency, reduce their operational costs, and eliminate the work in silos. Nobody thought it could be done, but we did it. This is the 4th PolyWorks conference at which we're presenting the evolution of our CMM solution. Some of you already use it and love it. Some have started testing it and are planning to switch, but others have not tried it yet. But this year is special. This year, we are absolutely sure that after seeing this presentation, that the majority of you will want to test our CMM solution. In the first part of today's presentation, my colleague Martin will present key customer requests that we have chosen to implement in the 2019 release. Then I'll come back on stage to present how PolyWorks 2019 dramatically speeds up the creation of CNC CMM measurement sequences. Martin?
Thank you, Richard. Good morning. And let's begin with some core functionalities that we developed based on requests from customers like you. As you'll see in the next few slides, most of them have to do with supporting additional hardware. In terms of probing heads, PolyWorks now directly supports the PH10M IQ Plus head from Renishaw. This head adds inferred calibration to the traditional PH10M, making it possible to measure with multiple tool orientations with no need to calibrate each one. Once your probe head is calibrated, all you have to do is calibrate your tool once and you're good to go. The PH10M IQ extends the portfolio of inferred probe heads supported by PolyWorks, which already includes PHS heads from Renishaw, as well as Zeiss heads such as CSC and RDS. Those of you who use Zeiss heads will be pleased to know that when a Zeiss articulated head is used, PolyWorks now displays head angles using the Zeiss convention. As I'm sure you're aware if you're a Zeiss user, this convention is opposite to the Renishaw convention, on which PolyWorks had been standardized in the past. Now that PolyWorks is adopting the hardware-specific angle convention, you'll work with the angles you expect from the hardware you're using. And if you need to adjust a measurement sequence from one type of hardware to another, PolyWorks will automatically recompute the angles. When you measure symmetrical parts, no matter if you're using a single machine or a multi-arm setup, mirroring sequence steps may save you considerable time. PolyWorks 2019 improves how tool orientation steps are mirrored. Here's an asymmetrical probe head. When it's mirrored, PolyWorks now makes sure the swivel is correctly positioned to avoid any possible collision. In the same manner, if a star stylus is used, PolyWorks will select the appropriate tip to use on the mirrored side while keeping the mirrored probe head orientation. With these enhancements, PolyWorks, your mirror tool will closely match the original tool as closely as possible. Tactile scanning. This is an ongoing request from those of you in the powertrain industry and from mechanical parts manufacturing in general. This is a way to quickly collect points by keeping the probe in continuous contact with the surface. Thanks to the high density of data points, tactile scanning is ideal for controlling form error. PolyWorks now supports scanning circles, cylinders, and cones using circular paths. But this is just a first step. Expect more types of objects to be supported in the months to come. In terms of tactile scanning hardware, PolyWorks supports Renisha SP25M, Hexagon, HPS X1, 3, and 5, also known as LSP, and Zeiss Vast XT and XXT. CMM laser scanning is a very powerful tool. It allows you to measure parts much faster than probing. And PolyWorks will gather clean and reliable scan data thanks to real-time quality meshing. In this 2019 release, we offer a new scanning possibility by supporting Zeiss Eagle Eye scanners. This is in addition to the already supported complete range of Creon and Nikon CMM scanners on LK controllers, Pantech Eagle, and Wenzel 2040. Here's an interesting new functionality that can speed up your laser scanning processes. When you only need to control specific characteristics such as holes or trimmed edges, it's useless to scan the surfaces in between. By specifying go-to points in a scan path, the scanner can move at a faster speed between the features of interest. This was previously possible, but multiple scanning paths would have been required. With this enhanced scan path, you get optimal scanning speed with a lighter measurement sequence. That's it for new hardware support. Now, yesterday, we've demonstrated that PolyWorks allows you to script customized measurement methods and integrate them as standard measurement methods. Well, I have good news for you. It works for CMMs too. Historically, CMM users had a lot of flexibility with the DMIS language to program special measurement methods tailored to their needs. To offer the same flexibility, we now allow you to script custom CMM measurement methods. And since they're directly embedded within measurement objects, you don't even realize that they've been scripted. Let's see one example of a measurement method for a CMM. Typically, when measuring a trimmed edge, you'll use a back point to account for a surface deviation. With this back point, the location for the trimmed edge measurement is adjusted based on the measured surface deviation. You also have access to an iterative method that remeasures the back point and the edge point a second time to allow for more deviated parts. But if surface and edge deviations are significant, both standard approaches can fail. So this is a case where you may need to script a custom CMM measurement method. How would you solve this problem? There are many possible solutions, but a common approach is to use 2 back points instead of 1. This will allow the software to extrapolate the expected position of the edge so that the CMM measures it successfully. Let's have a look at how PolyWorks Inspector works once this method has been scripted and integrated. As we saw yesterday, you only need to select the object and right-click to launch the scripted measurement method. The script creates the back points, measures them, and adjusts the location for the trimmed edge measurement to measure it at the right location. And in the end, the trimmed edge point is moved back to its nominal location to report the right deviation. As we've seen with this example, PolyWorks now allows you to script custom CMM measurement methods, as you could do before with the DMIS language. Here are the key benefits. Since we're using the PolyWorks macro scripting language, Possibilities are endless. You can script whatever method you need. These custom measurement routines behave just like standard measurement methods. You can trigger them manually or from within a measurement sequence. And finally, these methods are stored in your user configurations, so you can reuse them in all your projects and share them with colleagues. Now back to Richard for quite an exciting new feature. Richard?
Thank you, Martin. Since the beginning of our CMM development project in 2011, our mission has always been to offer a modern, user-friendly CMM software. Our early adopters' feedback shows that we chose the right approach. We're hearing intuitive and easy to use when our CMM users talk about PolyWorks. But the feedback that pleases us the most is, I've learned it by myself. 2019 is an important year for us. After having introduced real-time collision analysis technology and launched collision avoidance tools, it's now time to leverage these technologies to bring the user-friendliness to the sequence creation process. There are 4 main challenges when creating a measurement sequence for a CNC CMM. First, you want to measure all objects. It's obvious, looks pretty simple, but in big projects, it can quickly become an issue to simply know if an object is handled by the sequence or not. Then, you want to measure each object with the proper tool orientation. CMM experts are good at knowing their A and B angles, but new CMM programmers, they can probably be helped by the software. Then you want to measure with the optimal order to minimize the measurement time. At the same time, you don't want to sort all those objects manually when dealing with hundreds of them. Finally, it's critical to avoid collision so that you don't damage your equipment. Historically, creating sequences for CNC CMM was not that easy, and it took quite a bit of time to do. Well, that's about to change. We're pleased to announce that PolyWorks 2019 offers a new assisted sequencing technology that will dramatically speed up and simplify the creation of measurement sequence for CNC CMM. To convince you of the vast potential of this new technology, let me play a time-lapse video that shows how a full CMM sequence was created in just 5 minutes for a manifold. Let me explain the sequence creation process that you've seen in this video. First, the operator set the measurement parameters. Then he pre-aligned the part by manually probing a single point. Then the operator added the datums. This is where the assisted sequencing technology was first used. The operator simply selected the datums, and PolyWorks figured out the optimal order to measure them without collision. A datum-based alignment was then created, and finally, all the remaining objects were intelligently added to the sequence in a single click. Let's now summarize the key calculations that were performed by this new assisted sequencing technology. First of all, this assisted sequencing technology ensures that each object will be measured with the proper tool orientation. It does this by analyzing the measurement object geometry and the current list of calibrated tool orientations. A new tool orientation will only be added if needed. Then it makes sure to minimize the measurement time by finding the right order to measure all those objects. Then the assisted sequencing technology will add all the go-to points automatically to prevent any collision between the CMM and the part. All this assistance makes the whole sequence creation process much faster than before. In these examples, PolyWorks was able to add up to 5 objects per second in new sequences. Try to beat that. I hope that by now you're excited about this new technology, but I know some of you, and I'm pretty sure you want more. So let me invite my colleague Amanda for a live demonstration.
Thank you, Richard. Good morning, everybody. So, during the next minutes, I will create a new measurement sequence interactively. Then, I will show you how a completed measurement sequence can be optimally edited. And finally, we will analyze the complete measurement path. The part that will be used is the inner hood of a vehicle, and the inspection plan is divided in 4 views. The top view contains mainly the holes, the left, the right, and the front views contain comparison points that will be used to measure the deviations along the contour of the part. And the goal is to include all these objects in the measurement sequence so they can be efficiently measured by CNC probe. The sequence contains already the measurement context and the CMM pre-alignment. But as you know, it is recommended to switch to a more robust alignment as soon as possible. In this case, using these 3 tooling bolts. Upon enabling the mode to edit the sequence interactively, a toolbar is presented offering different functionalities to assist you during the creation of the sequence. Having the alignment spheres already identified, it is just a matter of adding them to the sequence. The spheres features are not just added, they are added in an optimized order along with go-to positions that ensure the safety of the machine displacements. Checking out the generated path, here at the back, we can see that without this go-to position, the tool will collide with the part when trying to reach the sphere at the back. So we're positive the path is collision-free. Let's run the steps to measure the spheres and use them for the alignment. The alignment that will be performed in this case will be a best fit on measurement object, which is already here. And now let's continue with the creation of the sequence. And the process is simple. Enable the interactive mode, select the objects, and add them to the sequence. One more time, select the objects, and I'm currently using the interactive tool, which is this one here, to select objects interactively in the 3D scene. So object selected, one more time, add to sequence. So easy, right? No need to worry about the order of the steps or go to positions, and more important, the safety of the equipment thanks to the collision detection algorithm that runs actively calculating safe paths. However, there are certain situations where the calculated path cannot be generated collision-free. But keep calm, PolyWorks got your back. When a potential collision is detected, the affected step is flagged in the sequence, and the problematic path is highlighted in the 3D scene. Taking a closer look, here we can see that the collision takes place between the measurement points of the plane, something that is related to the measurement parameters of it. Additionally, mousing over it, the Analyze Path mode can be launched, and here we can navigate to the detected collision to display the tool at the location where the collision takes place. And this is something that we can easily fix back to the interactive mode by adding a go-to position interactively close to the location where the collision takes place, clearing this way the problem. Note that go-to positions can be added interactively to any path segment, which includes path segments between measurement objects and path segments between measurement points. Now, this seems too good to be true, right? Telling the software what we want to measure and the rest, it just happens. Really? Well, yes, really. It is good and it is true. And what about tool orientations? Where are they? Well, tool orientations are also calculated, as it was already mentioned. And a clear example is this hole here, where the proper tool orientation capable of accessing the inner area is required. But because actions speak louder than words, let's select the objects one more time and add them to the sequence. When adding objects interactively to the sequence, part of the path calculation involves validating if the last tool orientation in the sequence is or can safely probe the selected objects. And if not, well, a more adequate one is inserted, maximizing the number of objects that can be probed without collision. Taking a look at the added steps in the sequence, this is the slotted hole that we were just talking about, and a couple of steps before the tool orientation. But there is another collision detected, as you can see here. And when looking at the 3D scene, the problematic path is not as obvious as the previous one. So here, mousing over the flag, the Analyze Path mode can be launched directly from there. And here we can change the viewpoint to center on the current step to better display what the issue would be. Navigating the path, here we see that there is a pin inserted in the hole, and the tool is going right through it. Another issue related to the measurement parameters of this object. So changing how this hole is measured using the pin and hole method should result in a more adequate path. It is effectively a more adequate path, but still not a safe one. Navigating the path one more time, we can see that the tool is still too close to the surfaces when following the path. So additional parameters will need to be adjusted to send the tool to a safer distance from the surfaces when following the path. No more collisions. Let's continue with the creation of the sequence by adding the remaining objects. One more time, select the objects. And as you can see, it's very easy to identify which are the objects that haven't been added yet to the sequence because these are the only ones showing. And that display is controlled by the hide objects added to the sequence available from the toolbar. So one more time, object selected, add to sequence. In summary, the optimizing measurement sequence process takes care of three main operations. The first one, calculating the shortest path, which involves the optimal order of the steps, and validating tool orientations. The second one, analyzing for potential collisions, and the third one, well, generating the safe path, which we have already here. So analyzing here the final portion of our sequence, we can see that from this side, it goes over the front area and then to the other side. Tool orientations added when needed, and also go to positions when required to avoid collisions. Let me just show you what the complete path looks like. And as you can see, it's a very clean and optimal path. But just when we thought that we were ready to run the sequence and go home, additional measurements need to be added. In this case, for example, information about surface deviations for the central area of the part is required. So let me just create the object that will allow us to measure such deviations, so comparison points, using a text file. And here they are. And I'm sure some of you have experienced a similar situation at some point. Once the sequence is complete, like in this case, additional measurements need to be added for more detailed reports, a CAD revision with new features to control, or simply some of the measurements were forgotten and were not added to the sequence. Typically, when dealing with such scenarios, up to now, is to add them at the end of the sequence because it is difficult, and let's face it, time-consuming, to try to find their proper location throughout the sequence without redoing it again. Here, where the points are all over the part, adding them at the end of the sequence would definitely not be the most efficient way to measure them because the machine was over that area gathering data before. So yes, we're going to add them. Points already selected here. But we're going to add them to their optimal location. So what is already in place is taken in consideration and adjusted to include these new objects at the right locations throughout the sequence. And voila. As you can see here in the sequence, the objects are added at their optimal location, and they are integrating optimally and efficiently to the existing path. It took roughly, 10 minutes-ish to create the complete sequence, fix issues, and add new measurements to the complete sequence. And I'm taking the time to explain you guys things here and there. Bottom line, it shines for what it is, ladies and gentlemen. A great tool that assists you during the creation of the sequence, taking care of those painful and time-consuming operations along the way. But this isn't over yet. There's still one more thing that I want to show you. And it is related to this object here. Let me just zoom in. This slot needs to be measured following a specific methodology. Its position needs to be validated, but as you can see here, there is a pin inserted. So what will be effectively probed is the pin while still using the parameters of the slot object. And all of this will be accomplished using a macro script, which is already defined as measurement method, as it was already presented. But the beauty of this is that you can customize how to measure objects and still take the advantage of including them directly into your CNC CMM sequence. So as any of the previous objects that I've been working with so far, I would just select it, enable the interactive mode, and add it to the sequence. At this point, at the optimal location, because the sequence is complete. And once again, you can see that it integrates optimally and efficiently to the existing path. Now, why was it included to this path and not this one, since it's the one that seems to be closer? Well, the reason is this path here is using a tool orientation that is not compatible to measure that hole. In the sequence, it displays with the name of the macro script, which is the measurement method, and the name of the object. So the sequence is now complete, as you can see. To review it, just launch the Analyze Path mode, which is the same tool that we have used to analyze and review the collisions, but it is also a very powerful tool to navigate the measurement sequence without launching any measurements. And all of this was done in offline mode, but it can be perfectly done online. So when finished reviewing and analyzing the measurement sequence and positive that everything is as desired, well, just run the sequence and get those measurements done. As simple as that. I will now invite my colleague Richard back to the stage. Thank you very much.
Thank you, Amanda. At this point, I'd like to invite Carl Graves from General Motors. Carl has accepted the offer to test our solution a few months ago, so he agreed to share his experience. So thank you, Carl, for being here today.
Good morning, everybody.
So, Carl, can you just tell us a little bit about you, what you do, and how you use PolyWorks?
Well, sure. I've been at GM for about 35 years now. Originally, I started out as a pattern maker. That kind of tells my age. And then I turned into a metal model maker, right? And I've had many different positions, from paint shop supervisor to maintenance supervisor. But currently, I'm the dimensional manager for pre-production operations and in charge of new technology for scanning on our CMMs. We tested out this we test out all this new technology before we move it out to our plants, right? So we use PolyWorks for scanning in all three of our buildings, and we scan everything from dies to whole vehicles for root cause analysis. We currently use PolyWorks on all of our CMMs. We have 14 CMMs and 8 portable workstations. One of the things we're doing with PolyWorks too, which is unique right now, castings come in and we scan those ahead of time, and it saves quite a bit of machine time down the road because we can put the Tyhesion in the middle of that die and find out where we got extra stock or no stock. So that's been a real savings for us.
All right. And as I said, we contacted you a few months ago, see if you wanted to test a few things on the 2019 release. So can you tell us a little bit what you've tested?
So we tested the sequence creation tool on our sheet metal parts, right? Everything from small little brackets to hood inners. Also, we do a lot of research work for our scientists. And we did some hubs, engine covers, and check aids and fixtures and things of that nature. Some of this work used to take us 4 to 6 hours to do, right? With this new creation tool, it takes about 15 or 20 minutes depending on how many parameters we got to change in the software. So it's been a real game changer for us.
Interesting. And have you tested it on larger projects as well?
Yes, we actually tested it on a full body in white, which is quite complicated. And that used to take us about 16 hours to do, right? So the last job we did, it took about 2.5 hours, depending on how many parameters I had to change or probe orientations I had to recalibrate.
All right, interesting.
And one little last thing I'd like to say, you know, I got great leadership at GM that allows me to do and test all these new things, right?
Yeah. So yeah, I mean, what are the main benefits for you and GM about this new technology?
Well, currently my team is about half the size it used to be 15 years ago, right? So back then we used to send people out to the plants to help out with programming and do things of that nature. Now we've become so much more efficient using PolyWorks. We're actually asked to do programming for the plants and do some scanning work on CMMs for our plants. In the past, we used to pay outside companies to do that, so now in the future, my team's going to do that, so I don't have to send real dollars to the street to pay companies to do that, right? And just last week, my boss said to me, he said, "Hey, Carl, I am not opposed to sending people to the plants anymore to help out." So it's been a real cost saver for us.
Good. Finally, anything else you want to add?
Well, for me personally, it's made my job a lot more interesting and a lot more fun. I actually get to program with my team, and my team loves using PolyWorks. The assistant sequence tool has become a real game changer for our CMM users. As a matter of fact, one of your colleagues, he took my slogan and put it on LinkedIn. And just one last thing I would like to say to people at Intermetric, always make you feel like you're as one team and working together, right? And they got a way of drawing people in together, and it's just been really great working with them. And I would like to thank the people at LK, Nikon, and Hexagon for working with us too to make all this possible.
Well, thanks, Carl, for sharing this. I'm sure the crowd loves it.
Thank you.
So, what are the key benefits of this new assisted sequencing technology? First of all, we've made sequence creation quick and easy so that anyone in your team can now program CMMs. Then, since everything is selection-based, you are still in charge of the sequencing process. It's the operator that chooses the measurement tool, that handles the complex geometry, while PolyWorks automates the repetitive tasks. Finally, the assisted sequencing technology works both offline and online, as does our entire CMM solution. This concludes today's presentation on PolyWorks 2019 CMM metrology.